Well, we're continuing on with section 1.1. We talked about performing an analysis using statistics. And here's an example. Here's the research question here. Would students return money, say $20 found on the street, to the owner? So you see someone drop $20 on the street, and they just keep on walking, and you come up to the money and you pick it up. Do you just put it in your pocket because they didn't notice, or do you go run up to them and try to give it back to them? What are you going to do? The method that the researcher is going to use is he's going to ask 100 students what they would do, and then find the percent who say they would return the money to the owner. So he did that, collected the data. So somehow he got 100 students to talk to. Maybe he stood outside of the student center. Maybe he sent them emails. I'm doing some research. I need to ask you just a short question. Can you help me so I can do my research? I need it for my mid-semester project. Pick a reason, so they'll call you back. I usually don't even reply to most of the requests for data because I don't really know why they want it. Sometimes they want something else besides just the data, and then you just end up having to work too hard. And a lot of people just go, I'm just not going to do it. So that's a problem with data collection. People don't answer the phone. It's from a number they don't recognize. They don't open email if it's somebody they don't know because of all these things that can go wrong when you do that. Like you get a virus on your computer, or people start sending you advertising, all kinds of stuff. So he did that anyway. Somehow he found a way. And 67 of the 100 said, you know what? If I see someone drop money on the street and I'm walking along behind them, and they don't bother picking it up, I'm thinking what I would think is, well, if they don't care, maybe I could use that money. But they said what? 67 of the 100 said yes. I would pick the money up and try to return it to the owner. So we go, okay, can we use that? Well, we're going to find the percent. So 67 out of 100, we can find the percent. You could find out that, you know what, they didn't quite say yes or no. Someone that said, well, it would depend on something, 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 and blah, blah, blah. And so you can't compute a percent because you didn't have an actual solid percent that said yes, and that's what you thought you were going to use. And then you have to go back and redo your analysis. But we got it here. It says 67 said, sure, I'll do it. Fine. And then you have a further check. So they got a percent all right. But wait a second. How do we know if they were telling the truth? Seems to me, if you're involved in a survey situation, you're more likely to behave honestly, at least in your mind, than you might in real life. So possibly, if they really were in the situation, they go, I could use the $20, and the person that dropped it doesn't look like he needs it, and so I'm just going to keep it. But in the survey they're giving, I'm just going to say, sure, I'm not dishonest. If I see someone drop money, I'll give it back. So we're worried about that, but we continue on, and we give our results. It says 67% said yes, but that is only a sample. That reflects the sample alone. And that might not even be the truth for the sample. So not only is it a small group of people, and that percentage isn't going to represent the percent for all students, but what they said might not even be the truth. So that's the limitations of the results. And then we keep going. A consultant says that the true value for all students is probably only within about 9% of that value. So the actual percent would be 9% below and 9% above. Well, 58 is 9 less and 76 is 9 above. So the actual percent of students that will return the money is somewhere between 58 and 76%, subject to those limitations that maybe they're not telling the truth. So the 9% takes into account the fact that I'm only using a sample to estimate the value of all students, of a population. Anytime you use a sample to estimate the population, there's going to be this margin of error, as we call it. In addition to that, there's this problem that the number we have may not even be accurate for the sample, and so you have to take it all with a grain of salt. All right, so we did that. So that's how that kind of stuff looks. And we continue on with more definitions. So the more definitions we have, here it comes, variables. So far we had parameters, statistics, sample, population. Now we have variables. The measured quantities made of individuals are called variables. So over here, the variable was, did they say yes or no? They're called variables because they vary from individual to individual. The collected values are called the data set. Oh, a data set. The individuals are often identified by a name or number. These are not usually These are not usually called variables because they're just names and numbers. They're not something that's varying because of the thing we're trying to study. It's just a way of keeping track of who or what we contacted. So an example of variables, and as usual, we're using as individuals, the students in this class. Possible variables for the students in the class would be SAT scores, age, gender, ethnicity, hometown, phone number, major, anything you could ask them. There's PID number, I guess we still have PIDs. Student ID number, I'll put that here, ID number someplace. ID number. The reason why we're talking about these variables is later on, in fact, in a few minutes, we're going to talk about classifying variables as either quantitative or categorical. And then further beyond that, in the notion of categorical, we'll have certain kinds of categorical variables. For quantitative variables, we'll have certain kinds of quantitative variables. See, some of these things are numbers, some of them aren't. So ordinarily, numbers are quantitative, except for things like phone number and ID number. Since they don't represent an amount, they're considered categorical and not quantitative. But things that represent a score on a test or an age, things like that, where you're measuring something, how big is it, how many points did you get, and you can compare scores. It makes sense to compare scores and ages, but phone numbers, you don't compare them by adding and subtracting along with ID numbers. So if you can't add them or subtract them, probably they're not quantitative variables. And we'll be talking about that next slide. And just close this slide off, I guess, and here we go.